Okay, so we're continuing on with applications of quadratic equations. So we've gotten some applications involving area. Okay, so here's another one. So it says a rectangular lawn measures 30 by 20. In order to put a hedge, a strip of grass of uniform width has to be cut along the outside of your lawn. So if I drew a rectangle here, okay, I want to cut like that, okay. Hedge is going to go here, so it's this is grass is going to be cut away. Okay, it says uniform width. That means the width of the grass that's cut away, not the overall width of the whole rectangle, but that is the same as this all the way around. So from that distance to here is x, from there to there is x. Okay, so it's cut from all four sides, leaving only 62.5% of the original amount of grass. Determine the width of the strip that was cut. So you're trying to find x. So let x be width. So if you don't have a diagram, then for sure you have to have a let statement. Okay, but if you have a diagram, I'm okay with you as long as you label it correctly on there. All right, so this is where, remember, I said I don't put area of the whole thing anymore because when you read that on the board, it doesn't look so good. Area of the entire rectangle is 30 by 20. Okay, I'm not going to put units in till the end. Okay, the area of the inside is 62.5% of that. Okay, well, what's the area of the inside? We need length times width. So here, if this whole thing, so this was 30, and this was 20. So if that whole thing is 30, and I'm subtracting this x and this x, then that's going to be 30 minus 2x. Here, this is 20 minus x, so 20 minus 2x. Okay, so that your area of your inside is going to be that, whatever you get when you multiply through. You can do it now or you can wait. And now you have to relate those somehow, right? So it says the area, so you cut out the grass, it says leave there by leaving only 62.5% of the original amount. So that means this equals 62.5% of this. So therefore, 30 minus 2x times 20 minus 2x equals 0.625 times 600. So now expand, get everything on one side, and solve that quadratic. So it's not a question where you're maximizing the area or minimizing it. You're told what the area has to be. So it's a solving question. Okay, so you can solve whatever method you want. Check if you can factor. If you don't want to bother with that, use quadratic formula. I would tend to stay away from completing the square. It's a whole lot of work, right? And really, quadratic formula is completing the square in one step. So unless you're asked to solve by completing the square, then see if you can factor. If not, quadratic formula. In this case, you can factor, because that's going to be two numbers that multiply to 900 and add to negative 100. So negative 90 and negative 10. So and actually factor. Okay, so this one doesn't make sense for the diagram. That would be, what, 22.5? Well, you don't even have enough to cut out on the width for that. Okay. I did convert it to a decimal because it's an application question. Certainly you can give fractions as well. Okay, here's a triangle type question. I think a good one similar to this. Yeah. Okay, so very similar. You're going to use the Pythagorean theorem to help you with this one. We did one like this already. So we have a 90-degree triangle. Hypotenuse is 50. Perimeter is 120. Okay, so perimeter, we call this x and y. Then x plus y plus 50 equals 120. So really, x plus y equals 70. This one you can actually sort of trial and error it and get the answer, but we give this to you on a test. We want to see the algebraic work for it, right? So here, x squared plus y squared equals 50 squared. So this perimeter is what we want to use to express x in terms of y or y in terms of x. So I'm going to solve this for y. Okay, in terms of let statements, if you didn't have a diagram, let x and y be the legs of the right triangle. Okay, so you'd be solving that equation. So square, or get rid of the brackets, select like terms, get everything to one side, and solve it. Got to square the 50, so that's going to be here. Oops. There we go. And that's going to be 24. Right? And that's going to be 12. Okay, so you get two possible values for x. So if x equals 40, put it back in here and you get y equals 30, which is the other x value. Remember, sometimes the x's aren't actually your final answer. In this case, it does give each other, okay? But you want to write a statement. So the lengths of the legs of the right triangle, in this case centimeters, so 40 centimeters and 30 centimeters. Right, yeah, just check it in here. So y would be 70 minus 40 is 30. So put 30 in there. Equals 40. Right, so we kind of give each other. Okay, so this one's a number type question. So 3 consecutive odd natural numbers such that the sum of the squares of the first two is 15 less than the square of the third. Squares. Okay, so remember an expression for an odd number. It would be something like 2x plus 1 or 2x minus 1. So if we let x be a natural number, so if we let x be a natural number, then 2x minus 1 is an odd number. So if you think natural number, the smallest is 1. So 2 times 1 is 2, minus 1 is 1. That gives you your smallest odd number. Okay, then 3 consecutive. Therefore, 2x. So we take this and add 2 to it. And then we add 2 to that. On the next 2 consecutive odd numbers. Okay. So then the sum of the squares of the first two. So smallest. Now you could start at 2x plus 1. You could start at 2x plus 9. Any odd number here, but keep the number small, right? So sum of the squares of the first two is 15 less than, so you want your minus 15 at the end, the square of the third. Don't put 15 minus, right? So it's 15 at the end, subtract 15. So now, square everything out, solve that equation. Okay, so those, what did I do wrong now?
I'm not sure, but should it be minus 15 on the other side if the first two numbers is 15 less than the third one?
No, the sum of the squares of the first two means equals 15 less than the square of the third. Sum of the squares is equal to 15 less than this. You can add 15 over here if you want. But it's going to be, this is going to be a bigger number. So is always means equals. So 15 less than the bigger square. So taking a look at this, you're not done, right? Yes, x is odd, but 1 is odd, but 2 isn't. So you need to think about your consecutive odd numbers. So if x equals 1, then you would have 2 times 1 minus 1, 2 times 1 plus 1, and 2 times 1 plus 3. So that means you'd have 1, 3, and 5. When x equals 2, we have 2 times 2 minus 1, 2 times 2 plus 1, 2 times 2 plus 3. So you have 3, 5, and 7. Okay, and then you can check them out. So 1 squared plus 3 squared. Okay, now this one, will this make sense because of positives and negatives, right? So that's going to be 10. 5 squared is 25 minus 15 equals 10. So yeah. Then that's your verification. And then 3 squared plus 5 squared. What's that? 25 plus 9 is 34. 7 squared minus 15. 49 minus 15 is 34. So there are 2 sets that work.
When you got your X values, how many substitutions are subject value satisfied with given the one you're doing the percentage count.
Could be either, right? So you want to verify, right? Sometimes you get something that's inadmissible. It just doesn't, the equation that forms, that you formed doesn't make sense for that application. So, you should also check the work too. So this is another area question. So square pool with that side length of 16 meters, surrounded by rubberized floor coverings, a visual pool where they put, like it's just to surround the pool, so it's nice when you get out of it. It says of uniform width, so that's the same thing. That width around it is the same. Okay. If the area of the floor covering equals the area of the pool, determine the width of that floor covering. Okay, so I would draw a square and an inside square. Square and an outside square, depending if we want to think about it. Okay, so this is 16 meters, same all the way around. And your floor covering, that's X. Uniform means the same all the way around. Or equal, right? So that width is X, this is X, this is X, this is X. So your outside dimensions then will be 16 plus 2X. So that will be the first, this because it's a square, right? So you know, in this case, you know the area of the inside is 16 squared. The area of the entire thing is 16 plus 2x all squared. Okay. So there's a couple ways you can go about doing this. It says the area of the floor covering equals the area of the pool. So how do you get the area of the floor covering? That's this, right, is the entire area, this, minus the pool, okay? And that's equal to the pool, right? So think about that. Really, if this shaded equals the area inside, then the whole thing is twice the area of the inside. Right? So if this we find A, if this is equal to the area of the shaded, then that's A. So the entire outside, entire here, is equal to 2A. So therefore, 16 plus 2x squared is 2 times 16 squared. Okay. And then that's what you solve. So that's going to be negative. I think we have to use quadratic formula.